Hello, I'm Professor Rad, and today we're going to talk about different kinds of numbers. In the last video, we talked about signed numbers sort of in general, so we had positives and negatives. Today we're going to break it down a little bit more. So I'm going to start out with a note here about notation. One of the things that often trips us up in a math class sometimes isn't actually the math part, it's just how mathematicians have chosen to represent things. So I once had a math teacher who said mathematicians are lazy and that's why they came up with all these symbols and shortcuts. And so it's kind of like we have to read and interpret their secret code. So that's what this is going to be about with our notation. So sometimes the notation for positive and negative numbers can look a little different from just using a plus or a minus. So for example, if you see a number and there isn't a sign attached to it, it's a positive number. So numbers are assumed to be positive unless they have a minus sign. So for example, if you see just a 5, it's understood to be a positive 5. Also, sometimes negative numbers are written with parentheses around them. So for example, you might see -5 with parentheses around it instead of just -5. I think the reason that we use like a naked number, a number without a sign to mean a positive, is because you tend to use positive numbers more often, right? As you're like counting or accumulating things, we just come across them more often. So we get this shortcut, we don't have to write that plus in front. And I think these parentheses ended up being used because we wanted to avoid confusion between subtracting a 5 and a -5. So sometimes they'll put parentheses around a negative number so that you don't confuse this minus with a subtraction. Now let's define a new type of number. So for example, we've got whole numbers and natural numbers that we've talked about so far. This new type is called an integer. An integer is a positive or negative whole number. So think of all like the whole number amounts that you could have, and if you make them positive or negative, then they become integers. So there are a few different ways that we can list out the integers. One way is by using a double ellipses. So you have a dot, dot, dot at the beginning, and then you can write out a -3, -2, -1, 0, 1, 2, 3, and then a dot, dot, dot. And what these two sets of ellipses are indicating is that not only does this list continue forever going forward, it continues going forever going backwards as well. Now, a shortcut way of writing this would be to start out with 0, and then you could write plus or -1, plus or -2, plus or -3, dot, 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 to indicate that this pattern's going on forever. So both of these lists represent the same set. They both represent integers, and they're all the positive and negative whole numbers. So think about the numbers you count with, making them negative or including 0. And when you have the plus minus in front of the number, this is standing in for two numbers, -1 and +1. But there's an important note here. Remember that not all negative numbers are integers. So for example, if I have a -2.57, this is not an integer. It's a signed number because it has a negative sign in front of it, but it's not an integer because it's not a whole number amount. It doesn't show up on these lists. If we want to talk about all the different kinds of negatives, all the different kinds of decimal numbers, so positive decimals, negative decimals, and so on, then we're going to refer to them as the real numbers. So the real numbers are all decimal numbers. So you could have positive decimals or negative decimals. Those are real numbers. In fact, any kind of number that you are likely to think of is probably going to be a real number. There are some numbers that are not real, but we're not going to get into them in this class because you mostly use real numbers. So for example, if I have the number 5, number 5 is a natural number because the natural numbers are numbers that we come across in counting. So when you count 1, 2, 3, 4, 5, 5 is a natural number. It's also a whole number because the whole numbers are all the naturals and 0 tossed in. It's also an integer because it would show up a little bit later on our list. 1, 2, 3, 4, 5. So 5 would be on our list of integers. It's also a real number because you could think of 5 with an unnecessary 0 or 2, right? So 5.0, that's a decimal number, and so that means it's a real number. So what this means is the real numbers include all of the other numbers we've looked at so far. So I've got a picture. If you're a more visual person, let's look at a picture of what the different kinds of numbers we've talked about look like in relationship to each other. Okay, so we've got this series of boxes here to represent that, like, this box of numbers is contained within this other box of numbers, and so on. The insidemost box, these are our counting numbers. These are the natural numbers. So inside this box would be 1, 2, 3, 4, 5, 6, 7, 8, 9 forever. The natural numbers are contained within the whole numbers. And that's because the whole numbers is any number that's natural, and then we toss in 0. The whole numbers are contained in our newly defined integers. So 0, 1, 2, 3, 4, 5, those are whole numbers, but they are also integers. But the set of integers contains some numbers that are not whole, like -6. -6 is an integer, but the negative numbers are not whole numbers. And then, as we just said, you can represent any of these numbers in decimal format. So then you get the real numbers. So the real numbers contain the integers, which contain the whole numbers, which contain the natural numbers. And in each of these containments, there are some of the bigger space that are not part of the smaller space. So for example, there are some real numbers that are not integers, but every integer is a real number because it's included in the real number box. So we're going to do an example of identifying the different types of like categories, or what types of numbers each of these belong to. So let's start out with 10. When you're counting, do you end up getting to 10? Yeah. So that means 10 is a natural number. So I'm going to check off that 10 is a natural number. I'm going to bring back my visualization. Notice that natural numbers are included in the whole numbers, the integers, and the reals because they're inside each of those boxes. What that means is since 10 is a natural number, that's also going to make it a whole number, an integer, and a real number. So 10 fits all of these number types. Let's look at 0. Now when we start counting, you start counting with 1. So 0 is not included when you start with your natural numbers. It is the only number that's a whole number that's not natural. So that means 0 is a whole number. If I go back to my visualization, if I'm living in the whole number box, that means I also live in the integer and the real number boxes as well. So not only is 0 a whole number, but it is an integer and a real number. Okay, so let's look at 5.71. If we're counting, we would count 1, 2, 3, 4, 5, 6, 7, 8. We don't stop somewhere in the line to pause to get to 5.71. So that means 5.71, it's not a natural number, and it's not a whole number, and it's not an integer. So natural numbers, whole numbers, and integers are special in that anything that comes after a decimal point has to be 0. If it's not a 0 after a decimal point, it can't be any of those three. So 5.71 is an example of a real number that isn't any of the other kinds of numbers we've talked about so far. Let's look at plus 6. So remember that if you have a positive number, you could write it without the plus sign. So we're really just looking at 6 here. Is 6 one of those numbers when you start counting? Yeah, 6 is a natural number. And since the natural numbers are the insidemost box, it means that it's also whole and an integer and a real number. If we look at negative 0.15 and we relate it back to this 5.71, remember we said that if there's anything after a decimal point, it can't be natural or whole or an integer. So negative 15 hundredths is only real, doesn't fit any of the others. Now negative 15 is a kind of interesting one because 15 is a number when we're counting, but negative 15 isn't, right? When you're counting, you're just counting positive or whole positive amounts, right? So it's not natural and it's not whole, but it's a negative whole number. That means it's an integer. And all numbers are real numbers that we're going to look at in this class, so it's also a real number. So negative 15 is an example of an integer that is neither natural nor whole. And the last one for this example is a positive 8 7/10. Again, we've got some stuff happening after the decimal point, so it's not natural, it's not whole, it's not an integer, so the only thing it is a real number. Okay, so here are some numbers for you to try and classify on your own. So now you can try to classify negative 26, a positive 82, a negative 6.5, a positive 11, and a 0. So see if you can identify what type of numbers each of these numbers is going to be. In our next video, we're going to finish up section or chapter 3a by talking about something called the absolute value. So I'm looking forward to seeing you then. In the meantime, have a wonderful day.